Well, welcome, and for those with jet lag, hopefully you can still hold through another presentation. But today what we want to talk about is remote workload visualization and how to optimize that for organizations. So first, what are some of the problems that people are starting with? One, certainly, even though HPC has been doubling every 18 months, data has been doubling basically every year. We have those that have been doing visualization on their desktops and are beginning to see that, yeah, they can put GPUs, they can add a lot of memory, they can add try to get more and more cores on those workstations, but in many cases really need to be able to scale beyond an individual workstation to be able to get their work accomplished as well. And then also those that are seeing increasingly that they need to collaborate in the overall picture of their compute environment. So additional challenges that people are dealing with. So first of all, those workstations which they have been buying to do some of the visualization, in many cases they're significantly underutilizing them. If you go into a traditional workstation space, if you buy someone a workstation, they will use it effectively 5 to 15% of the time. Now, it's not saying during the workday, but that's saying it around the 24-hour period when 365, that it's very underutilized and in many cases not always utilizing the expensive GPU or other resource that you might have put on it. Also, as people are beginning to move around significant data sets, if you're in the oil and gas space and you're trying to move up and down data sets to look at it, there can be substantial wait times. If you are in manufacturing and you're trying to move up and down different large data sets there, that also can be a significant wait time and waste. And so either you can continue to try to build out the network of your WAN and your internet and your LAN and other types of resources, or you can try to approach it in a different way. Users sometimes don't even have access to the GPUs that they need because the organization can't afford to give every single workstation a GPU because it's so expensive. We have collaboration is difficult, sometimes because of they need to have access to it, but they're at different physical locations. And so you have to move the data around to all of those that you might want to be able to collaborating with. You also have those that need to work with other partners. So it's not just people inside the organization, but they need to work with other organizations that are outside. And honestly, they can't necessarily give all the IP of what they have in their data, but they still need to collaborate. So how do they do that? You've got, again, the wait times of the data transfers. In security, when you move the data to a desktop, you've created a security problem. It's not as secure. And when you begin to move it to a bunch of desktops, your security problem is increased. People can walk away with that data simply or access that computer and get that information. While there's a better approach with remote visualization to not have to get that security problem. And low utilization and scalability of the specialized resource. And also, most people, when they're doing a calculation or doing some work, are really just doing one step in a multi-step process. You don't build a car with a single calculation. You do things that are helping you at the beginning of the process to look at the materials. You have things that help you build the structures. You have things that help you crash it and see the impact on those materials. You look at the airflow and whether or not you have good efficiency. So ultimately, you have to be able to get workflows in place, whether it be manufacturing, whether it be oil and gas, whether it be life sciences, that are taking things from one step to the next step through multiple applications to be able to get an overall project or overall product completed. So what is a good engine to be able to make this successful? One, visualization is key in this. It's helping to speed innovation and discovery. It's helping people to reduce the costs of their products and reduce the cost of producing their products, and it's improving the overall quality. So what I did is I basically tried to create a mock scenario of an organization of what their problems are, how they look at some of the different alternatives to be able to solve those problems, and ultimately what choices they make in terms of technology to be able to help solve that. So in this scenario, we've come up with next-gen manufacturing enterprises. Okay? This mock company is a mid-sized manufacturer. They are one that have to go out and they have to win bids that are competitive bids, and they need, against their chief competitors, they got to have better quality, and if they figure out how to reduce their costs, they need to collaborate with multiple suppliers, so they're not just solving a single part, but they have to work with multiple suppliers. They have 50 high-skilled designers that are involved in this. They have GPU-accelerated applications, Windows and Linux applications, and semi-distributed teams that are working on this. They have a good LAN, but fairly slow wide area network, and some of their users are actually accessing things over the internet. So that's their situation. And their challenge is management comes in and says, hey, we've got a great deal for you. We're going to give you a bonus if you can figure out how to do this with, there's 20% more work we have to accomplish, we have less time, and we're going to cut your personnel budget by $300,000, so we're going to cut a few people from the budget team because that's how competitive the deal was, but we need to win this. So what's the plan that you can put in place that's going to help you reduce the budgets, reduce the time to accomplish it? So where are you going to find those efficiencies? And as they tried to look at this problem, they said, well, some of the places we're working in silos. We're competing with an individual application, solving a single problem, and we throw it over the wall. Someone has another process with those applications. So one of the things is they're going to shift from the siloed processes to an integrated workflow, end-to-end, and try to shrink the time that it's required to be able to get there. They're going to try to improve the productivity of their users by about 10%. That's some of what's going to allow them to do it with fewer personnel. And they're going to overcome the data wait times of moving the data back and forth amongst the different desktops. And they're going to shift from something that was just taking all of their requests to being able to find the critical path priorities first, so that they're making sure that they're focusing their workload on the right elements first, reducing their costs. They're going to shift from redundant resources out of the desktops to shared resources, and they're going to, again, we talked about the shifting of to the priority-based decisions. So what might be pitched to them? So first of all, we're not a hardware vendor, so this is just saying the total scenario that might be done between us as a software vendor in conjunction with some system integrator or hardware vendor that might be able to go out there. So one, we would come in and pitch the Moab HPC Remote Visualization Edition that focuses on improving the productivity when they have 2D and 3D apps, increasing the collaboration, and protecting the data. We also reduce the cost through being able to share more resources with this overall solution. But that's going to be what we're going to suggest to them. What's made up inside of this is, one, the tool creates a portal or has a portal which allows you to come in, whether you're coming in from a laptop, whether you're coming in from an iPad, whether you're coming in from a desktop. We have some oil and gas customers that they want to be out at the site of the location using their iPad and manipulating the reservoirs. And you have others that want to be able to do, in a manufacturing process, maybe even on the floor, the looking at the designs through thin clients or other desktop tools. So first of all is giving the sessions to multiple different types of devices. Second is doing management of those sessions on the Linux side with being able to say how many resources an individual can have, what are the constraints that you want to do as you're trying to allocate. Because once you share, you're no longer saying this is your desktop. You now have the ability to say you can have much more or less of everything out there. Resource management, there's ability to do this on Linux and Windows. And also it's key that it's not shifting the data, it's just pushing over the pixels. And so you also want to be able to compress that so that you can get a lot higher efficiency and have a better quality if you have a poor connection. And then down here, you have the traditional ability to do Linux many-to-one. If you want to have Windows many-to-one, because of Windows, you have to have a hypervisor technology. If you don't use that hypervisor technology, then you can still have one-to-one mapping, and we'll get more into that in subsequent slides. So further education, and again, this is a scenario where with the solution, you're able to have your different users and consumers from different places across the globe to be able to come in, access what normally was big sets of data, and now simply interact with that data in a shared visualization cluster, but yet do it from remote locations, allowing to have the different designers participate. So again, we already talked about the different devices that you're able to come into, and this is what the experience might be like. So here's Fluent, here's PAM Crash, here's Abacus, and again, here we chose a manufacturing scenario because that was our customer set, as opposed to oil and gas or other types of tools. And then you, right in the screen, able to pull up the 3D visualization, manipulate it. And some of the nice things of what it does is as you manipulate it, if you are doing it over wide area network or the internet, you can have it so it actually reduces the quality as you're moving it around, and the moment you stop, it snaps into full quality, so that you have the maximum performance of moving things around, but yet when you want to actually look at things, you can see it in very detailed view. You have, as mentioned, the network, the compression that is also getting you some added performance. And what's key is this solution from some is actually you can only set it at the server level, so everybody gets the same quality. That's not the case here. We're able to, on a per user basis, or perhaps even per client or device basis, determine what that is, so that someone over the internet may be getting one setting, someone on a high-speed local area network may change the different settings, and you can optimize to each of them. But what's key is, as we looked at other solutions, this had 2.5 to 5 times better quality for the same level of performance, or 2.5 times less bandwidth required for the same quality experience than other solutions. As mentioned, this might be the experience, so you've just used one of the applications, you've produced some data. Now, as part of the workflow, you want to instantly open up that data right into the next application. So with this, you can help create some of those workflow experiences, so you're not solving things in a silo, you're building out the full workflow experience from the beginning step out to the full product at the far side of it. This is just an example, and again, we just chose the manufacturing scenario here. There's others for life sciences, for oil and gas, etc. But here, good experience with things like Abacus, with Altair Hypermesh, with ANSYS, with many different types of the common applications that people use within this space. Part of the key is you make a decision, is you can find some solutions that may have 1 year of experience or 2 years, but they're not going to have the depth of integration with different applications. Because the solution has been around 5, 6, 7 years, now you have the beginnings of a library of applications that are already created and already optimized for this particular space. Now the built-in sharing, so now you're in this experience and you're saying, I want to share with user X, user Y, and allow them to all simultaneously come in and actually see, just as I go into something like a GoToMeeting or another type of tool, to kind of have that shared experience and have multiple users, and I can say, allow this person to manipulate the screen and what we're looking at. You can do the same thing here so that you have people coming in and manipulating it. We've had examples in the oil and gas space where, again, they can't ship the data, not only because it's too big, but because it's proprietary, but yet they can talk to someone that needs to participate in the overall supply decision or the overall value delivery, and allow them to also look at the visualization experience of what is there to allow them to make better decisions. So certainly from a workload management perspective, we're going to do automation of session allocations. On the Linux side, we're going to manage the number of users per server, users per GPU, priority. We're going to improve the overall utilization of these systems. And again, in terms of model, on Linux, just by native, you can get multiple users consuming a single blade or a single server. On Windows, you can start with the one-to-one, where you are just dedicating an individual server to a user, or if you add in virtualization, then you can get a many-to-one. The big picture is you're probably trying to achieve maybe a 4-to-1 sharing of GPU-based resources, or 4-to-1 sharing of some of these centralized visualization resources. You can get higher. You can choose to go lower. 4 is just kind of a common space of what people are doing. So in terms of the misaligned offering, this is what people are doing now. Is they're saying, well, I want to get, for my 50 users, I'm going to have 10 come in and they're going to get an NVIDIA Quadro system with a bunch of memory. It's $16,000 per workstation. And some getting some mid-sized NVIDIA mid-end systems, $7,000. So and I put 40 users there, 10 there. I spent $400,000, and I haven't looked at the energy cost and waste. I haven't looked at the network costs required to move that data up and down. And not only that, I didn't get sharing because I put it out at the workstation. I have redundant purchases of GPUs. I have excessive maintenance because I'm having to look at all those specialized desktops, and it's a lot more costly to keep up a whole bunch of specialized desktops than it is to put it into a Viz cluster and maintain a centralized Viz cluster. You have more backup problems, more energy and network costs, and then all kinds of other things such as time loss as you're moving things up and down, IP issues, security issues. So that's how people are doing it a lot of times. This is the suggestion. Don't do it that way. Create a Viz cluster. And here I just used HP as the manufacturer. Certainly you could do this with any other manufacturer, but with the 4-to-1, I'm buying 2 of those blades, 10 of those blades. If you look at my total hardware, I did $200,000 instead of $400,000, but that is not why you buy it. You don't buy it because of the hardware. You buy it because of the personnel savings. If I have to take a piece of data and move it up, it takes me 10 minutes, move it down 10 minutes, and do that twice, I'm close to my 10% of my day. 48 minutes is 10% of your day. If you take that across the personnel for 3 years, the 50 people, that's $2.5 million of lost productivity. That's why you make the purchase decision, is because you want to get your product to market faster, you want to get your results faster. And so yes, hardware also saves you, but really it's that productivity in the end. And again, you don't have to build out the network as fast because you're not moving the data. You're just moving pixels, and those pixels are basically going to be the same size from then on out. Some change with some quality improvements over time, but it's much more controllable of what your capacity needs are going to be over time. So the comparison, without the solution, long wait times, inefficient collaboration, complexity in learning versus just the opposite. Hardware costs are reduced, productivity is significantly improved, and it just becomes a really good ROI decision when you look at visualization and having the right tools. So my hope is that I've convinced you that this is the right model. So now the obvious question comes, well, great. Are there other solutions beyond what you have? Well, the answer is yes. Let's look at some of those other solutions. So here's the Moab Remote Visualization powered by Nice DCV. And some other solutions that we see out there is Citrix, Microsoft, HP has Remote RGS, Virtual GL is a solution that is out there, and that's some things that you'll see from some of our other workload management competitors build things around that. And let's look at some of the fundamentals. So if I want Linux, well, I can either use our solution, RGS, or Virtual GL. But if I want Windows, I can't use Virtual GL. So, and if I want session sharing, I can only use this and that. So really, if you know that you're going to have Windows and Linux, and you want to be able to share the GPUs, there's really only one solution that's coming out with a clear answer there. So that quickly says the others are very incomplete solutions. This is really the only one that's going to get you there. But even if that wasn't the case, and you said, I'm just Linux or I'm just Windows, then we look at this advantages, for example, against Virtual GL. If it was just a Linux scenario, this is the bandwidth savings. 2.5 to 5 times better for the, either if you're trying to get the same quality experience between the two solutions, you'll get 2.5 to 5 times lower network requirement to have the same quality with this solution versus something that's based on virtual GL. And that's part of having to do with the compression. That's part of the intelligence of being able to manipulate things and snap to high quality afterwards is a lot of those savings. So the choice for them for next gen is obvious. They need Windows and Linux. They need the cost savings. They want to share the GPUs. They definitely want the 2.5 to 5 times better performance. They want the ease of use. They want to collaborate. They want to break down those silos with the workflow management. They really have their eye on that $2.6 million savings, and they have the confidence that this is a solution that's been out there for multiple years and is very experienced in terms of integrating with different applications. So that's what they choose. They choose Moab Remote Visualization Edition, and certainly we invite you to do the same thing. So I know that a lot of this is repetitive at this point, but these are the reasons that you would want to come to us, and we invite you to come to booth 500 to be able to have additional conversations with us about the remote visualization solutions, what we're doing now, what we're doing out into the future. And at this point, I'd be happy to entertain any questions.